ECE section. Today's my topic is probability of error in BPSK and QPSK. Introduction. What is probability of error? BPSK basic content, BPSK signal representation, probability of error in BPSK, QPSK basic concept, QPSK signal representation, probability of error in QPSK. Why BPSK and QPSK have same BR? Advantages, applications and conclusion. Introduction. Digital communication systems transmit information using digital signals through the communication channels. During transmission, signals are affected by noise and interference, which may cause errors at the receiver. To evaluate the reliability and performance of digital communication systems, the probability of error is an important parameter. Binary phase shift keying and quadrature phase shift keying are widely used digital modulation techniques. BPSK transmits 1 bit per symbol using 2 different phases, while QPSK transmits 2 bits per symbol using 4 different phases. Both modulation schemes are commonly used in wireless communication systems because of their efficient performance in noisy environments. In this presentation, we analyze the probability of the error in BPSK and QPSK, their working principles, and compare their performance in terms of bit error rate, that is a BER. Under the presence of noise, what is the probability of error? Probability of error is the chance that the received bit is different from the transmitted bit during data transmission in a communication system. In digital communication, signal travel through the channels that contain noise and interference. Because of this noise, and the receiver may sometimes detect the wrong bit, which causes an error. Definition. Probability of error is defined the probability that transmitted symbol or bit is incorrectly detected at the receiver. Formula. General formula. PE. It is called the P of received bit is not equals to transmitted bit. Simple example. If A0 is transmitted due to noise, the receiver detects 1. This is called a bit error. BPSK binary phase shift key is a digital modulation technique in which the phase of a carrier signal is changed to represent binary data and 0 and 1 in BPSK to different phases. Values of the carrier wave are used to transmit information. 0% phase that represented binary 1. 180 degrees phase represented binary 0. This means the carrier signal shifts its phase by 180 degrees. Whenever the binary data changes, key points. BPSK uses 2 phases states. It transmits 1 bit per symbol. It is simple and highly reliable. It has good noise immunity compared to many other modulation techniques. Simple explanation. When the input data is 1, the signal is transmitted with noise phase. When the input data is 0, the signal is transmitted with phase reversed 180 degree shift. BPSK signal representation. In binary phase shift keying, binary data is transmitted by changing the phase of the carrier signal. Two signals with 180 degrees phase difference represent binary 0 and 1. Mathematical representation. The transmitted BPSK signals are for binary 1, S1 of t equals to square root of 2 EB by TB cos 2 pi FCT. For binary 0, S2 of t equals to minus square root of 2 EB by TB cos 2 pi FCT, where the EB is the energy per bit, where TB is the bit duration, FC is the carrier frequency, T is the time. Explanation. The two signals differ only in phase. Binary 1 uses the original carrier signal. Binary 0 uses the inverted carrier signal. Probability error in BPSK. In BPSK, the probability of error represents the chance that the receiver detects the wrong bit due to the noise in the communication channel. When the transmitted signal passes through the additive white Gaussian noise AWGN channel, noise may change the signal amplitude and cause incorrect detection. Bit error probability. The probability of bit error for BPSK is given by PB equals to Q of square root of 2EB by TB. 2EB by N naught, where PB equals to probability of bit error, EB is the energy per bit, N naught is the noise per spectral density, Q of x equals to Q function. Q of x equals to 1 by square root of 2 pi n into integration x to pi e power minus t square by 2 into dt. QPSK basic concept. Quadrature phase shift keying is a digital modulation technique in which the phase of the carrier signal is changed to represent digital data. In QPSK, 4 different phase values are used to represent data. Since your 4 phases are used, each symbol represents 2 bits of information. Phase representation. The 4 phase representations are typically 0, 0 equals to 0 degrees, 0, 1 equals to 90 degrees, 0, 1, 1 equals to 180 degrees, 1, 0 equals to 270 degrees. Thus, 2 bits are transmitted in one symbol, which increases the data rate and bandwidth efficiency. BPSK signal representation. In quadrature phase shift keying, digital data is transmitted by changing the phase of the carrier signal into 4 different values. Each phase represents 2 bits of data. Mathematically representation. The QPSK signal can be represented as S1 of t equals to square root of 2 EB by Ts cos of 2 pi FCT plus theta naught, theta of t, where E equals to energy per signal, Ts equals to symbol duration, Fc equals to carrier frequency, theta t equals to phase of the signal. Probability error in QPSK. QPSK, the probability error is the chance the receiver detects the wrong bits due to the noise in the channel. QPSK transmits 2 bits per symbol using 4 different phase states. The bit error probability of QPSK is PB equals to Q of square root of 2EB by N naught. Why BPSK and QPSK have same BER? It is a bit error rate. BPSK and QPSK have the same bit error rate when transmitted over an AWGN channel with the coherent detection. Reasons. QPSK can be considered as two independent using two independent BPSK systems operating simultaneously. One in the in phase first I content, one of the quadrature Q content. Explanation. In BPSK, 1 bit is transmitted using 2 phase states. In QPSK, 2 bits are transmitted per symbol, but each bit is carried by separate orthogonal carriers I and Q. Advantages. Advantages of BPSK and advantages of QPSK. Simple modulation and demodulation technique. Better noise immunity compared to many other modulation schemes. Low probability of error due to the large distance between constellation points. Reliable communication in noisy channels. Widely used in satellite and deep space communication. Advantages of QPSK. High bandwidth efficiency than BPSK. Transmit 2 bits per symbol, increasing the data rate. Better spectral efficiency in communication systems. Applications of BPSK and QPSK. Satellite communication systems, deep space communication, military communication systems, RFID systems, low data rate wireless communication. Applications of QPSK. Cellular communication system, 3G, 4G, 5G, Wi-Fi networks, digital television broadcasting, satellite communication, higher rate wireless communication systems. Conclusion. BPSK and QPSK are important digital modulation techniques used in modern communication systems. BPSK transmits 1 bit per symbol using 2 phase states. and provides good noise immunity. QPSK transmitted the 2 bits per symbol using 4 states, which improves bandwidth efficiency and data rate. Both signal modulation schemes have the same bit error rate performance in an AWGN channel. Thank you, sir.